Welcome, ladies and gentlemen, to kick off our day. Please welcome Stan Humphries and Jazz Thind.
Hey, good morning. I'm Stan Humphries, Chief Analytics Officer for Zillow Group. Really excited about today, the conversations we're going to have. Over the almost 14 years now that since we started Zillow, I'd say that analytics, by which I mean kind of the full spectrum of analytics, everything from marketing and business analytics to data science to machine learning to artificial intelligence, has really been a very central part of our culture. I think one of the best testaments to that fact is the fact that our first two unique products were in fact analytic ones. An estimated home value we placed in every home in America called the Zestimate, and then a housing index which we computed down to the neighborhood and zip code level, which back in 2005 was really unprecedented. These first products were, of course, just the start. And over the years, kind of that initial spark of those products has kind of rippled throughout the company in a number of analytic products along the way. You know, I think not only internal within Zillow, but I think over those years also we have found a lot of other innovators that are doing and tackling similar problems. So at about the same time we were dreaming of Zestimates up in Seattle, a band of entrepreneurs was down here, right here in the Mission District, working on innovating on real estate search experience for what eventually would become Trulia. And literally a team of people were working in a condo in suburban DC in what would eventually become Hot Pads, which is the nation's one of the nation's largest real estate websites. Rental websites. And in Manhattan, Street Easy was getting formed around that same time. So today, Zillow Group has, you know, is a kind of multi-brand family that includes Zillow and Trulia and Street Easy, Naked Apartments, Realestate.com, Loop. And others, but all of those brands have the same mission, which is to create the largest, most trusted real estate marketplace in the world. And AI and machine learning have been really central to that mission along the way. This has never been more so than today, when our companies are now embarking on actually direct buying of homes through Zillow Offers, and as of last month, getting into mortgage origination. We're really passionate about AI and ML, and we really believe that these transaction processes and mortgage processes are really ripe for the application of AI. So we're really excited about kind of what comes next.
Yeah, at Zillow Group, we have invested in many areas in the space of machine learning and artificial intelligence. We have a team of scientists and engineers who are working on a variety of problems, such as search and natural language understanding, personalization and recommendation systems, Zestimates and automated home price predictions, image classification and deep neural networks, 3D computer vision and virtual tours, ad tech and ad optimization algorithms, and many other real estate-related machine learning and ranking problems. For me personally, I'm very excited about the massive opportunity to make people's lives better in real estate using machine learning and artificial intelligence. There are many interesting and exciting problems to solve, and I'm sure many of us here are tackling many of the similar challenges. And really the goal of this forum is to bring together thought leaders, all of you in this room together, to explore creative solutions to the problems, issues, and questions that we are all facing as we go about and build our own products.
Yeah, so we're super excited about the conversations we're going to have today, all the sharing of ideas among other technologists and scientists today. You know, we think it's you know, we're kind of we feel like we're at a stage of development for AI where it's still pretty early days here, and we're pretty excited about kind of sharing these ideas across companies, because we do think that kind of sharing the breadth and the depth of what's happening in AI is the best way to kind of help all our companies at this point of development for AI. So we're excited about sharing all these ideas across multiple companies that are really leading the way in AI. To get us started today, I'm really excited about introducing Mario Vinasco, who runs marketing analytics at Uber. Before that was at Facebook, and did his grad work here at Stanford in the Bay Area. So Mario, come on up.
Thank you very much, Ben.
Yeah.
Thanks, Jazz, for the very nice invitation. It's always very exciting to speak, especially in this beautiful city of San Francisco that I'm privileged to call home, many of you, in a beautiful morning. I work for Uber in the marketing analytics group, and then we employed all the tricks in the data science book in order to manage the communication with our users, user retention, user acquisition, etc., etc. I'm going to share with you some of those use cases and how specifically we use machine learning and artificial intelligence to do that. I'm going to give you a very brief introduction to artificial intelligence. Most of you already know this, but it's in order to develop the intuition and the dialogue with our marketing partners. We are going to do this machine learning in order to serve our stakeholders in marketing to do better campaigns, better measurement, better analysis, better targeting. And then it's important to have the intuition behind it. And one of the key things for data scientists is how to explain how these models work specifically to marketers. So I'm going to give you a very brief introduction to what it is, so to develop that intuition. And then I'm going to show you some use cases, very specific cases on where you use that for communication frequency and some optimization, what we are doing. By now, everybody knows this. Accuracy in image classification is the standard artificial intelligence 101. Every artificial intelligence course starts with these kind of things. What is amazing is that 4 years ago, this thing was very, very difficult for computers, as you know. In 2013 and 2014, correctly classifying cats and dogs would take an insurmountable amount of computing power, no algorithms, no hardware, no data, but some breakthroughs came along in these very short 4 years that seems like ages, seems like decades, right? One of the breakthroughs is how to represent data that is non-numeric as numeric. So they split it in pixels, they split it into amounts of red, blue, and green, that kind of thing. So instead of having an image, you represent it by 200 by 200, that's 40,000 times 320,000 data points. That was one of the breakthroughs, how to represent images as numbers such that neural networks could understand that. Then obviously the neuron that has been around for a long, long time, you all know this, is a simple weighted average of the inputs in order to produce some kind of output. And then the other breakthrough was to collect many of those neurons in many layers, and in many stacked vertically and horizontally, and somewhere in here, somewhere in one of those dots is where the magic of artificial intelligence happens. We don't yet know exactly where, but somewhere in there, those networks are able to learn the representation of those images. And obviously, that coupled with a very smart, what they call cost functions, meaning that how far is my guess away from my true label, and I navigate that function of the cost function until I reach something that is a maximum or a minimum. Those breakthroughs is what really constitutes the magic of artificial intelligence, machine learning and classification. That's a standard 101 artificial intelligence that obviously for people that are not in data science or programming, is a little bit surprising, but for most of you, probably not. Why I'm telling you this? We are not in the business of classifying cats and dogs. We are not in the business, at least not the marketing group. We are not, we might, right? We might. But we are not doing computer vision. What we are doing is customer retention acquisition. We are very interested in knowing if these are my Uber drivers, who of those drivers are going to churn next month? Who is going to stop driving for Uber? If you are a rider, who is going to order and eat in the next trip on a weekend? I'm very interested in those things. But at the end, and the math behind it, and the principles behind it are pretty much the same. Cats and dogs. In this case, drivers that are going to continue driving for Uber, or drivers that are going to stop or are going to churn for Uber. Instead of the pixels, and instead of the 120,000 data points for those pixels, what I'm going to feed into my network or my decision tree is for how long they've been driving, how many hours, what are the fares, the distances, how the driver being served to the destinations that they want to go at the end of the day, things like that. I collect all of those variables. Imagine a very giant spreadsheet, Excel spreadsheet, where I collect all those 50, 100, 150 variables times the millions of drivers that we have. We take a look at the past. We know who stopped driving for Uber. We know who hasn't. And then we run that network. And that network learns the representation of the most likely drivers that are going to churn next month. So what is the trick? The trick is you run your drivers, you take your cohort of drivers that are active now, right? You run it and you score it through the model that you have, that you trained in the past. That model is going to produce probabilities. The model is not going to tell you who is going to churn. The model is going to produce a probability from 0 to 100. So imagine that you list them in a spreadsheet, in an Excel, simple spreadsheet. from highest probability to churn to lowest probability to churn. That's what you are doing. Then you have to cut it at some point. At some point, you have to say, okay, anybody that is above 80%, I am going to call them churners, meaning that these are the people that I strongly believe they are going to churn. Obviously, I get some true positives. If the model is any good, I'm going to get some of the true positives. But I'm going to also get false positives and false negatives. No model is perfect, and every model has that. For computer vision, just for context, the accuracy of that is in the 99.9%. It's truly amazing, computer vision, how it has advanced. In marketing, we are not there yet. In marketing, we are more in the accuracy of the 70, 75%. Precision and recall are much, much lower. But this is what is important about this. Do this mental exercise with me. Imagine that the churn rate is 10%. 10% of my drivers are going to churn. This is not real data by any means. This is just an example. 10% of my drivers churn. If I am a marketer and I want to prevent churn, and I do a random campaign to prevent churn, for every 100 people that I target, I catch, just by luck, I catch 10, right? 10% is my churn rate. Now I run this model, and I score them from high to low. The top 20, the top 2 deciles, right? Only 20% of the user base are going to capture half or more of the true churners. And that is the key insight for marketing. Instead of randomly targeting 100 to catch 10, I'm going to target 20 to catch 5 or 6. A much, much more efficient vehicle for marketing investment than before. So what we are using machine learning for and artificial intelligence for is a very powerful segmentation and targeting tool. I don't know what to do with these guys because I am not a marketer. But Mr. Marketer, I can identify them for you, I can score them, and I can tell you with high accuracy, high in terms of marketing, who they are and how to target them. Let me give you a much extreme example. When I was at Facebook, we were doing this for telco companies. Telco companies have a 1% churn per month, typically 1% AT&T, Verizon, América Móvil in Mexico, which is one of the largest telco groups in the world, 1% per month. Obviously, if your model predicts that no one will churn, you will be right 99% of the time, right? But that doesn't do you any good. However, we were able to do this, a model like this, where in the P20 recall, meaning the recall, the amount of true churners that I catch in my top 2 deciles was over 50%. Again, a very, very, very efficient marketing vehicle for investment. So this is the story that our marketers understand. This is the story that we can communicate well. We are not talking about maximizing the F score, not even precision and recall or accuracy. But it's something that we know, because we know the size of that. Marketers can relate to how many people are going to target that. They intuitively know how much that is going to cost me on Facebook, or on Google, or on display. They know that. And if we know how many people are we going to catch of interest, that is a very compelling story for them. That's what we do. I personally spent a lot of time trying to polish this story. Hopefully I was able to tell it well and you understood what it is. Because for me, data science is also about this, about how you communicate the results of these things and how you partner with your stakeholders to do that. It's not just the models and the algorithms. That's why I gave you this brief introduction to artificial intelligence, because I wanted to illustrate this specific insight, as I call it. To do that, brief introduction to the platforms that we have. Uber has open source this tool called Michelangelo. This one over here is an open source tool, very similar to TensorFlow, to Facebook FB Learner or Caffe, and many others. It's a very powerful tool. It doesn't have the latest and greatest algorithms, but it does have things that make our lives very easy. When you train a model, you have to collect the data, you have to extract it, you have to join, you have to transform it, you have to train the models, evaluate them, iterate, eventually deploy, and schedule things. All those things, if you do it like in a Jupyter notebook or yourself, those things are hard, just simply hard. Michelangelo does all of those things for you in a very elegant web interface, which is very simple. to use. You extract your data from Hive tables, you schedule your jobs, you schedule your queries, train and your models and deploy them at a scale, which is very important. Open source, but there are many others. There are many other things. So for people that come from smaller companies or people that say, hey, I don't have access to that kind of hardware, yes, you do. You do, because those tools are, you can download it in an Amazon Web Server instance, and it's very easy to do, extremely easy to do. No mystery there. So some of the fun that we have in data science is because we get to work on these projects that are, in many cases, unrelated. In many cases are problems for which we don't know if a solution exists. And then we have to brainstorm and then throw out ideas and, is this possible or not? One of the marketing executives asked the question, well, not one, but it was a question that many of them had, is how many emails should we send to our users? What is the right frequency? Should I send you 5 and then send you 10, or what is the right thing? As far as we know, or as far as I knew, or I know now, there is no neural network that can tell me what is the right frequency of communications for our users, right? And obviously, marketers and do what they do best. They send emails, and they have a hunch or an intuition about how these things work, and then we have one size fits all. And we send, 7 or 5 or whatever number it is to everyone, right? Because we want to communicate offers, we want to send promos, we want to communicate new product features, et cetera, et cetera. Not an easy problem to solve because we didn't know how to do this. But we knew that we had models for churn, we had models for email open, email subscription, we had models for cross-sell. We have all those, a collection of predictive models that we have built as segmentation tools again. And I said, how can we use those models to address this question, to help our partners in marketing to answer this very important question? Again, we had these two models. The model on the top is the open rate model, and the model on the bottom is the unsubscription rate model. If the model is any good, you should see something like that when you break things by decile. This is a neat trick that we do all the time. Instead of looking at hundreds and hundreds of segments and probabilities, you just break it in deciles. Deciles are groups of 10% of equal size. That's what decile means, obviously. So if it's any good, what you will notice is the lower deciles have very low open rates, and the top deciles have extremely high open rates, meaning that the model has discriminatory power, right? That's what you want. You don't want random things. You don't want an average. You want that kind of distinction. Nothing is perfect. You have people that are in the lower deciles is still open, and people in the top deciles that still don't open. Obviously, you have positive, false negatives, all that kind of thing. But then you have these two models. And then the same thing for the unsubscription rate. You have the deciles, and then the top decile for unsubscription has extremely high unsubscription rates. That's what the model is telling us. We have those two models. How do we answer the question about what is the right frequency of emails? We then employ tricks and heuristics and discussions. So instead of having a 10 by 10 matrix, 100 segments that is very hard to manipulate, let's simplify. Let's just simply do high, medium, and low, high, medium, and low. How? By trial and error. By trial and error. Typically, high is the top 2 deciles, low is the bottom 2, and everybody else is low. Then you have now a much simpler matrix to work with. You have a 3 by 3, which is 9. And then you can ask this question. The segments in red. The segments in red are very high probability of unsubscription, right? Very high probability of unsubscription, and very low probability of open. What do you do with those guys? Well, again, there is no algorithm, there is no machine learning decision tree that can tell me what to do, but intuitively I know that I probably should decrease the frequency for those people, right? I should decrease. By how much? We don't know. But now we have a basis, we have a tools that can segment those people, and then we can do A/B tests on them, because I can identify them, right? And I can test those things. Similarly, for the people in green, we have a very high probability of the email being open, and very medium to low probability of unsubscription. So those people will probably benefit from higher communication frequency. Again, how much? I don't know. But we can test it, and we can do A/B tests, because now I know who they are. Now I can run those models, I have the scores, I can segment them very precisely into this matrix and know that. So that's how we address the problem of communication frequency. We believe that by doing this exercise, we projected an annual savings of up to 500,000 emails per year from unsubscription, which is very, very, very large. We send hundreds of millions of emails per year, and saving 500,000 of those from unsubscription is a big deal for marketing in terms of we preserve the relationship with our customers and the ability to communicate with them. So we use the models in a fairly creative way and a compelling story, and it was something that we have to polish in order to get to this point. And the reason I enjoy coming to these conferences is because I get to tell this story again. So next time that I have to meet with new marketers at the company, I am trained and I have perfected this story for them. So thanks for the invitation again to share these kind of things with you guys. Another way to see these predictive models, this is a cross-sell from writers to eaters. And then another way to see the power of these models is when you plot the actual conversion rate, which is the vertical axis, is the again, we're looking at deciles, cohorts of 10% size each. And then you plot that against the prediction score versus the actual, right? So you can see that the curve pretty much obeys, is a strong correlation. When I predict low, the conversion is very low, and when I predict high, the conversion is very high. So what is important about this is, Mr. Marketer, what are you going to do with these people? These people have very high prediction rates of converting, and they are indeed converting at, probably cannot see the 15, at 15 times the rate that everybody else. Maybe we don't have to do anything with them, right? Why would we bother? These guys are converting almost naturally, almost organically, or with very, very low incentives. Why do you have to send promotions or coupons to those people, right? These people on the left, on the extreme left, and I don't mean anything politically, by the way, on the extreme of my left, your left, these guys are not converting at all. They don't convert, short of throwing them $1,000 of food, right? Right, that's probably what you will have to do. You will have to send them like buckets of food to convert, and then why would you do that? That's not profitable. Then maybe you just forget about them. You don't do anything because they are not going to convert. And then maybe as a marketers, we focus in the middle. Someone in the middle are those people in the fence that with a little bit of incentive, and again, I don't know what incentive, I don't know what creative, I don't know what promo, but I'm not a marketer, I'm not a creative person, I'm a data scientist. But again, what I can sit down with the marketers is tell them who they are, we can isolate them, we can split that in test and control, and do testing on those. Because we are using, again, these machine learning models as powerful segmentation tools to exactly do that. So this is one of the exercises that we did at the cross-sell from writers to eaters. I recently moved to another team. This is previously, all that I mentioned was with the CRM team. The team still do that. It's still heavily involved in campaigns, predictive models. I moved 5 months ago or so to performance marketing, which is acquisition, spending money to acquire drivers, eaters, riders, couriers, you name it. And then we spend hundreds of millions of dollars doing that. Previously, the optimization was very crude, to say the least. Crude in the sense that we rely heavily on marketers. They know what Facebook performs better than Yahoo Display. Let's invest more there. Craigslist performs very well up to a point. That kind of optimization was what was happening. But when you spend hundreds of millions of dollars, you better be a little bit more sophisticated than that. And that's what we are trying to do. We are trying to understand how allocating money will move my KPI. In this case, if I spend money in San Francisco in the different marketing channels, how many trips or first trips or sign-ups or people that convert I'm going to get for that money. That's the objective function that we have. Maximize the driver trips, given a budget, given some constraints, and given some marketing channels that we have. And then it's a problem that is typically not a big data. This is not a big data problem. This is low data, because you are talking about cities, channels, and weeks, which is not that much, it's in the thousands, and lots of parameters to tune, lots of hyperparameters to tune. That's what an optimization problem is. MMM is this marketing modeling or media mix modeling discipline that was very popular in the 90s. For many people, there are a lot of young people here that probably don't remember the 90s. But it was popular, but it was just very difficult to do, very difficult to implement. We didn't have the hardware, the software, we didn't have gradient descent, machine learning, all those things. So MMM didn't work back there. That's my personal theory, because it was just very hard to estimate and attribute the efficiency of your marketing investment to your channels. Right? What we have now is an ability to attribute when we spend money. Obviously, you spend money, you see your KPIs move, how to produce these kind of curves, how to do the attribution and the performance. Optimization in particular is about this. It's about budget optimization. It's about estimating these curves, which are the efficiency curves, and I'm going to go a little bit into how we get that in order to optimize. Intuitively, you know, if you only have 9 curves, right, it's fairly easy to optimize. You don't need anything sophisticated to do that. Why? The more you invest, this is investment, and these are trips. The more you invest, the more trips you get, obviously. Up to a point, right, when you saturate that channel. Right? When do you stop investing? When your marginal returns start decreasing. And then you invest in something else, and then you invest in something else, and then you repeat the exercise. For 9 curves, it's extremely easy to do. You can do it by hand. And you will get probably the best results that the best solver you have. 9 curves is not a problem. But you don't have 9 curves. You have, in the US, we have top 50 cities. We have 9 or 13 or 15 channels per city, and then we optimize for a quarter. So when you multiply those things, all of a sudden, then you don't have 9 curves, you have 1,000, 1,500 curves. Then now you need to use something more sophisticated to do that, but the idea is the same. The idea is the optimizer will just choose the best points where your marginal returns start going down, and then you move that dollar somewhere else. And then you repeat the exercise until you get the maximum possible number of trips according to that. But what is the trick? The trick is how to get this curve, right? That is the trick. That is really the trick. Oh, the other things are also very hard, the forecast and the performance. But in my case, the trick is how to estimate this thing. And I think this is what killed MMM in the past, the ability to do that. What we know and what we have. What we have is we know how much money we spend. And again, this is just examples. Don't send a screenshot to TechCrunch saying that we spend this much in marketing at San Francisco. It's just examples that we have. I would be in deep trouble if something like that happens. You spend money offline, you spend money online in different channels, and then you observe in this case, your signups, right? Simple as that. Those are observations, those are facts. You can measure that. I spend money in San Francisco across many channels, and I get those many signups. For some, are very easy to attribute, right? If I see an ad on Craigslist, I click on Craigslist and sign up, it's very easy to do that. But if I see a billboard, then I Google search for it, and then I see also something on Facebook, how do you attribute those things? Those are much, much harder to do. So what we do is we employ a lot of data science models in order to do the attribution and the performance to create the cost curves of those. Again, you have these are the givens, and those are the outputs. And what we do is we employ, I don't know if you have heard this. This is a term that is not difficult to pronounce, but it sounds complicated. Bayesian structural time series. Remember Bayes, the Bayes theorem, all that thing? Okay, those are packages that can fit things to curves. In my view, they belong to the data science and specifically machine learning, because what those algorithms are doing is they are learning the representation of those curves over time based on inputs. So this is my input, the black line is my input, and I also enter not only the direct input, but I also enter other regressors. I spend money in San Francisco, I don't spend money in Los Angeles, but I also observe signups in Los Angeles. I also feed that time series to my model, and many, many, many other things. So those models are able to learn the representation of those curves. In this case, this is just a prototype. PyDLM is a Python equivalent of the BSTS program of the BSTS package in R. I prefer Python because it's much more elegant, it's easier to explain, but this is just a simple prototype. I feed the curve to that, and I ask, given that curve, project from weeks, the top thing, projects week 80 to 120, what would have happened? And then it gave me back the green curve. So what you can see is that the algorithm learned very well the representation of the seasonality, right? It learned the seasonality very well. It's not what happened. But so if instead it's not seasonality, but instead that was a big investment that I made, means that the PyDLM algorithm learned the representation of that, and now I can quantify it, right? Because I can see that difference. I can do some kind of regression between the green and the black to understand what would have happened again if I had invested that amount of money. And if I ask for the prediction from weeks 100 to 120, the prediction is much more closer to the actuals because it learns more, it takes more the history into consideration. So we use a lot of those things. This is very simplistic, by the way. The science behind it is more complex in terms of how we estimate those things. But again, we have time series of investment, time series of our KPIs. We have the channels that we know we invested in, and then we do this kind of modeling with those time series, with regressors and many other things in order to estimate that. And with that, we estimate these curves. Again, we go back to these curves. Those curves are estimated based on the learning of those time series to do the attribution. They are not perfect, but they are very good and very solid. And again, we feed all these curves to the optimizer, and the optimizer will give us back the red points of optimal investment in each one of those categories that maximizes trips. Another beauty of this is the dialogue that we can have with the planners. We have an optimizer that runs very, very fast. Typically, these things were very, very difficult to do because the optimizer will take a day to run, even for very few number of parameters. Now we have these optimizers that are called convex optimizers that work in minutes. Means that you can run multiple scenarios very quickly, and then if something is off, something doesn't make much sense, we can re-estimate these curves, rerun the optimizer, present the output again to the planners, and iterate on that until we get something that makes sense. And again, because this is a mix of data science and a mix of art and intuition and business sense. These people have been spending money for years. They know how to spend that money. They know intuitively how those channels work. And if something in the model is off or wrong, then obviously they'll let us know. And it's a partnership. We are not telling them to go as a mandate to spend, but it's a partnership with them on art and science on how we best do that. We, for the first time, did Q3 and Q4 for the US with this optimizer, and we are rolling that out to the world based on that. And again, it's thanks to the power of data science, being able to estimate those parameters very quickly and run the algorithms very quickly. Just to end, this is a neat trick that I recommend everyone. This is an Excel spreadsheet. Excel is something that data scientists don't use very much, and I think that is wrong. Excel has a bad reputation because Excel does not scale well. Obviously, you cannot do a production system in Excel, but Excel is great for prototyping. It's absolutely great for prototyping. If I show you the math behind my optimization problem, you will have a hard time understanding how that math means. But if I show you this and how these operations work and how I calculate each one of these little numbers, it's much, much easier to understand. So this is a very small prototype, 3 cities, 3 fake cities with fake coefficients, fake things fake turn trends, and this is how many trips I would get based on some spending. And I will get Excel solver, the solver within Excel, to solve that problem. And this helped me to visualize the problem, visualize the matrices, visualize the results, in order to move that into a much larger program in Python to do that. But this is really my base to do that. So I highly recommend that. When the planners question something, I open my Excel spreadsheet. Okay, let's make sure that we understand. Tell me if you want to beat. You think you can beat this number, 146 trips in this example, by investing the money that you invested before? Okay, let's plug those numbers in, and let's see how much we get. And if you beat the optimizer, yes, we go with your hunch, right? And it's very clear. They understand the math. They use this. They play with it. Now they are convinced that what we are doing works best than what they have. And obviously, for a problem like this, it's easy to beat or easy to do it manually. But obviously, if you have 50 of these cities, 13 of those weeks or 14, and 14 of these channels, then that's a problem that you will not do in Excel, right? You will not do in Excel. But you will visualize a small one in Excel. So with that, that's what I wanted to share with you. I shared with you marketing analytics, predictive models, and machine learning, and optimization. This is what I'm currently doing. We can open for questions, or I'll be around for more. And it's been a real pleasure to present here. Jazz and Stan, thank you very much. Thank you very much all for paying attention. And again.
Let's take 2 minutes for questions. Yeah.
It's not that different in my view, but there is one neat trick and there is one breakthrough in tabular data, which is called embeddings. So embeddings, let me give you an example, one extreme example at Facebook, for instance. You have millions of business pages. You have a Facebook account, I imagine? How many pages you think you have interacted with in your lifetime? 50, at the most 100, right? Most people will interact with 50 or 100. Nobody interacts with 5 million, 6 million pages. How do I represent the engagement of users with 6 million pages? I can do one hot encoding. I can create a 6 million vector with ones in the places that you have interacted with, but it will have 5.99 million zeros. There is a trick called embeddings where they reduce that to 128 numbers. And that's like a vector in multidimensional space that is extremely useful for tabular data, where you represent like holidays or other characteristics like that as embeddings. That's probably the only thing that is different. But everything else, the architectures, and we use a lot of gradient-boosted decision trees. Not much of neural networks, to be honest, because those networks are kind of opaque and dark. You don't understand the parameters. With trees, you understand those very, very clearly. Yeah. Sure. Yes, sir.
Yeah, you had a pretty nice way of classifying people into high churn, low churn. There's a related question that if I'm applying market treatment A to two different high churn problems, person A might respond very differently in terms of reducing churn than person B. How do you deal with that problem of marketing effectiveness?
So let me see if you understand. Let me try to rephrase it. When we run these models, we run them as a segmentation tool. When your score is very similar to his score, and then we cut, it means that the two of you are very similar regarding those characteristics, right? So it's homogeneous in terms of what the model is predicting. So I can cut you on a US test, and the other one is control, and that is homogeneous. That should work, in theory.
Right, but you might still act very differently to different marketing treatments.
Oh, yes.
We might both be high churn, but I'm actually willing, if you give me a bunch of coupons for promotions, I'm going to be low
Yes,
churn.
yes.
The other guy's just got lifted.
Yes, and that really depends on the predictors that you feed into your model too, because we have those things as predictors as well. Because you can think, we have many churn models, we don't have just one, many, depending on the predictors that we use, the time horizon that we have, but when you run a model on certain predictors, what you get is homogeneous, so you can split in A/B tests. And you should be able to read, that's the whole point. You'd be able to read the difference between the two because they are homogeneous. Yes.
Maybe we'll take Miley, your last question, and then.
Okay.
Yeah.
Can you just, that was really interesting on the media mix models and the time series. Could you tell me your official take on the media mix models? Like, would you still be using them? Do you still find them useful, or would you be moving away from them?
So the question is if we are still using and what is my take on MMM? We are currently using it. We use it as the umbrella methodology to estimate to do the attribution. There's just no other way that we know of that we can do that attribution. So yes, we are using it, but we are complementing it, and then we are replacing some of the previous algorithms with these machine learning estimations. That's why we are using it, yes. I believe we have one more.
When you said trees earlier, it could be GBM,
GBDM, typically the most, for tabular data works very well. Yeah.
Yeah, I think we should. But Mario, that was great. Thank you. And
Thank you very much.
He's also an author, so check out his book. Nice job, man. That was
Thank you.
awesome. Great job.